Hey guys, what we're getting into today is which I forgot to somehow title it, AA3-5, which is factoring higher degree polynomials. So to warm up, we're going to start writing these in standard form. For the purposes of this class, I'm going to use the box to multiply and to factor, simply because as we get into the higher degree polynomials, in my personal opinion, it becomes much easier to use the box. So I'm going to start with my factors on the outside when I have the factors, 2x plus 3 and x minus 5. And then I'm going to multiply each part out. So the 2x times the x gives me the 2x squared. 2x times negative 5 is going to give me negative 10x. X times positive 3, is going to give me 3x, and then 3 times negative 5 is going to give me negative 15. When I write it in standard form, I want to make sure to combine my like terms, both the x's. So my standard form is 2x squared minus 7x minus 15. To go the opposite direction and factor, as I've said before, there's multiple ways to do this, the most commonly known as the box and diamond. So we take the first term, the 2x squared, and we put it in one corner. Take the last term, the negative 28, and put it in the other corner. So when we multiply those to get our top number, we have negative 56x squared, and our bottom number is our middle term right there, negative 1x. So what I'm looking for are two terms for my sides that multiply together to give me negative 56 and add together to give me negative 1. For some people, those pop up right to your head, and for others, it's more of a struggle, so you can always list your factors. So 1 and 56. 56 divided by 2 is 28. 56 divided by 3 is not a whole number, so I'm not going to list it. 56 divided by 4 is 14. 56 divided by 5 is not a whole number, 6 is not a whole number, and then it's 7 and 8. In this case, we have both a negative and a negative for our top and bottom numbers. If they multiply together to give me a negative, I know one has to be negative, and if they add to give me a negative, then I know the bigger number has to be the negative. So the pair that works is 7 and negative 8, so 7x and negative 8x. So I'm going to put those in the empty boxes. Then I'm going to factor out the greatest common factor from any given row or column, but it's usually easiest to start either here or here. I'm going to start with the 8x, negative 8x, and the 2x squared. The greatest common factor there is 2x. Then I can fill in here 2x times x is 2x squared, 2x times negative 4 is negative 8x, and x times 7 is 7x. So I've got 2x plus 7 for one of my factors, and x minus 4 for the other factor. So basically what we're doing is we're taking this work and we're expanding it to higher degree polynomials, so where your exponents are higher than 2. Really quick to talk about what you can expect on the next test. I need to add, AA3-3 for the polynomial exact equations. So that's been talked about a few times, but you guys will get a review today, or got a review today if you missed my class. Okay, so what I have here is a series of puzzles that I want you guys to try to figure out various missing parts. So what we're really looking for is filling in the empty spots, figuring out what all those little question marks are. So what I would do if I were watching this for the first time is to pause right here and try to figure out what those side factors are and what the last little term inside the box is. Whether you paused or not, what we can do then is if we look at the first column, the greatest common factor there is x. So I'm going to take out a couple of those. So if I pull an x out there, I also know x times x is the only thing that's going to give me x squared. And then I know x times 3 is going to give me 3x. Over here I've got, erase those two. Oh, I have a pointer. So I need to know what I multiply 3 by to get 12, and that will give me this number. So that's 12 divided by 3 is 4. And then 4 times x is 4x. So my factored form is what's on the outside, so x plus 3 times x plus 4. My standard form is what's on the inside, simplified, and I need to make sure to combine my like terms, so my 3x and my 4x. So I always start with my highest exponent, x squared plus 7x plus 12. So now we're going to move on to a trivial. Again, I would recommend that you pause here, figure out, see if you can figure out the missing boxes and the side numbers. Hopefully you paused and you only need me to check. So right here I have this first term, and I also have that this is a 2x. If this is 2x and it needs to multiply to give me 2x to the third, the only thing I can have on the outside is x to the second. Then I can take x to the second and multiply it, or sorry, figure out what I multiply by x to the second to get 3x to the second, which can only be 3. From there, I know that 3 times whatever is here is going to multiply together to give me negative 30x. So negative 30x divided by the 3 will give me what goes down here, which is negative 10x. Then I can multiply negative 10x times 2x to get negative 20x squared. Back to the 3. 3 times something is going to give me 75. So 75 divided by 3 is 25. And then I can take 25 times 2x to give me 50x. That gives me my partially factored form of 2x plus 3 times x squared minus 10x plus 25. To fully factor, what I want to do is take this and factor it. You can use box and diamond like we did in the warm-up, or you can recognize that that is a perfect square trinomial. So you'll have your first factor, 2x plus 3, and this one ends up being x minus 5 times x minus 5, or you can also write that as x minus 5 squared. That's the factored form. The standard form, I'm going to put up above, 2x to the third. I'm going to combine my like terms. 3x squared plus negative 20x squared is negative 17x squared. Negative 30x plus 50x is 20x, so plus 20x plus 75. That gives me my standard form. So here's another puzzle for you. Again, I suggest that you pause and try to do this on your own. If not, you're probably not going to get quite as much out of it. So, hopefully you paused. We'll see. So, given the information I have, I really only have enough to figure out something from this row. Some students, when we did this, found the x squared part that can only be x and x. The other thing you can look at is this entire row and find the greatest common factor. The only thing you can divide all those by is an x. So one of your factors is this x plus 5 right there. So from that x, I can factor out that this is 2x to the second because I need the first term here to be 2x to the third. And then I multiply 2x to the second by 5. So I have 10x to the second. I also know that this one's going to be x because x times x gives me x squared. X times 5 is going to give me 5x right there. And then this last one is -1, and -1 times 5 is -5. So my factored form, partially factored form, is x plus 5 times 2x squared plus x minus 1. What this ends up factoring fully to is x plus 5 times 2x plus 1. No, 2x minus 1. And x plus 1. Double check that. Okay, so the reason that this is helpful to us, right, why we want to have these in factored form is because, like we've been working on lately, is that you can easily find the roots by finding the zeros for each of your factors. So for x plus 5, my root is -5. For 2x minus 1, do that off to the side. 2x minus 1, I set that equal to 0. Add 1, so I have 2x equals 1. Divide both sides by 2, so x equals 1/2. So that's my root for the middle factor. And then x plus 1, I have a root at -1. So it's easier to find your roots / x-intercepts by doing your factored form. So another puzzle, given a little bit less. I'm going to pause, and I'll just throw out the answers and leave them without explanation. You can just check your work. Maybe I don't want to do that just yet. So if I know that this is -6x squared, I divide that by -2 to get my first term here, 3x squared. I also know this first term is going to go in that box, so I can start there as well. The next thing I know about this is that something times x is going to give me -1x squared. So that needs to be -1x, or just -x. And I multiply -1x by -2 to get +2x. This is where a lot of people got stuck. So the other piece of information that we have is that our x's add together to get -22x. So if I add -24x, then these two are going to combine, the 2x and the -24x are going to combine to give me -22x. Then I can factor out the -24 and multiply -24 by -2 to get 48. So I've got -7, I'm going to write that in white, sorry, -7x for that term and 48 for the final term. And then I have my factored form, and I'll just do the partially factored form for now, of x minus 2 times 3x squared minus 1x minus 24. We'll worry a little bit more about fully factoring next time. The last little puzzle I'm going to give you is screwed up because the box is too small, and I don't know why. But this one gets to the heart of what I really want you to learn. So again, I would pause and see if you can figure this out, and then I will go over it. And this is essentially the process for how to do it. And this is more effective than the notes that I posted. So I would go to that and take notes on it if you want to, because I'm not going to do that step-by-step part here. But I'm going to explain it. So I start with my first term right here in the lower box, 5x to the third. I know that x times something gives me 5x to the third, so that's going to be 5x to the second. Then I multiply 5x squared by -6 to get -30x squared. Now I know that my x term is -19x squared. So to get from -30x squared to -19x squared, I need to add 11x squared. If you don't know how to find that, you can take what you have, the negative 19, and then subtract what you know. So negative 19 minus a negative 30 is going to give you 11x squared, and that's how you can figure that out. So then you factor out 11x, multiply again. Negative 6 times 11x is negative 66x. Same process as before. Now my x term is negative 64. To get from negative 66 to negative 64, I need to add 2. And then factor out a 2, multiply again, to negative 12. So my factored form, x minus 6 times 5x squared plus 11x plus 2. Jumping back to here, that's kind of the intro. We'll have a test next class, and then the following class we're going to be the day before Thanksgiving break, so we're not going to get into anything new, but we'll get further into factoring these higher degree polynomials. Have a lovely day. See you guys soon. So this one we're actually going to deal with next class. So